Hello and welcome back to the lab. Today on the bench we are continuing the calibration, alignment, and adjustment of this Tektronix 7854. In a couple previous videos we did the power supply, the tube geometry, the horizontal subsystem. We checked out the triggering system briefly, and we checked out the calibrator, also abridged and briefly. Next up, we're on to the vertical section, so we have two sections left to do before this frame is completely finished. We have the horizontal or the vertical section, and we have the digital section. So getting close, getting into the home stretch, but still quite a bit of work to do to get this thing up and kicking. And we have found some errors and needed to do some work, things like that, to get to this point. So definitely was something that was in need of doing, so we will continue. First one is vertical centering. Vert mode is left. Vertical trace separation B is mid-range. Trigger source is vert mode. Readout is off, and we're on scope, and we actually need to set this to alt and get some intensities going. That was initially a little confusing. So it's time-based B, vert mode, vertical mode, chop. That gives me the two lines that I need. We'll zoom in there real quick. And then these two lines need to overlap. They're close, but not quite. Okay. Now we're going to move to add. And that'll widen up the... So this is chop, this is add. Widens it up just a little bit. And then we need to adjust R20, 1/2 of the adjustment length. So about 1/4 of a division up. Okay, you want to go back and forth between those two resistors until the trace has minimal movement when switching from chop to add. So I think we have that pretty good. Okay, with a signal standardizer in COM mode and right vert selected, we need 1/2 a division to center. That's good. But we need to adjust. It's slightly off. It's like off by 1/4 of a division, or 1/2 a minor division, so 0.1. R105, well, it wants to adjust 105 and then check it and then balance it for left and right. So let's just check left real quick. Actually, since I have two standardizers, we'll just use that really fast so we can bounce back and forth between the two. I might be able to tighten that up just a little bit. Let's see what happens. Well, I think it's about as good as we're going to get it. It's a trace width below on left, and it's a trace width above on right. So that's probably about as good as we're going to get it. Step F3 we're actually not going to be able to do because F3 requires a analog test card, which I am actually in the process of recreating, but I have not been able to find any examples in existence, and I've been looking for a couple of years. The card number is 067-0912-00. So if anybody knows anybody with a test card or anything like that, I'd be really love to get my hands on one because we're trying to recreate it, bring it back. I have some boards drawn up, and I have some now 7854s that I can use as test modules to bring that back into existence. At the moment, it is just a concept. But that card is required for the vertical amplifier thermal compensations, R139 and R169. So not going to be able to do that. So we're going to leave them set as is, skip them, and we're going to skip to step F4, which is a vertical channel switching compensation. We need a standardizer and a time base. Okay, this one does need the signal standardizer, and we're going to test rep rates from 100 hertz to 1 megahertz and sweep rates, and we're looking for nice, even square waves at 6 divisions of display, and I'm actually pushing the scope a little too hard. Man, I have some dirty pots in this. So we're actually looking for good step response, no overshoot, no undershoot at given step rates. So that's 100 hertz and 5 milliseconds of division. Actually, we're at 2. Let's see if we can turn the readout on. Scope. No, it doesn't show us. Yeah, 2 milliseconds. So you guys will be able to see what's going on. So we'll do 1 kilohertz at 0.5. That looks good. 10 kilohertz at 50 mic. That looks good. 10 kilohertz again at 10 mic. That's looking okay with step response. Yeah, that's not going to be a problem. 100 kilohertz at 5 mic. Yeah, 5 microseconds. And that's looking okay. So I have to check the right side compartment now, but that's looking pretty good. We'll just buzz through this quickly. 5 mic, 0.5. That looks all right. 10 kilohertz, 50. That looks healthy. That also looks healthy. And 100. Yeah, right channel looks good as well. So all the compensations and the high frequency stuff is rock solid. Okay, we're into horizontal gain, and we're just off. Not too terrible. So we're going to tweak that just a bit, because what we want is as good as we can make it on the first 6. Okay, that's about as good as we're going to get it. On the vertical gain, we need to check the right side. All right, we're good on the left compartment, and we do need to give it some time to stabilize, warm back up, because this trace will stretch a little bit, and you'd even be able to see that as the plug-in warms back up from the momentary power outage to move the standardizer from the right side to the left side. Okay, setting up for the low frequency compensation, 2 divisions of display, and we move it down to the bottom. We're slightly compressed, just slightly. And if we move it up the top, we're slightly expanded, but it is within specification, barely. So this hits spec barely, so we can move on. For our high frequency compensation, we're looking at the step response of the vertical channel. 1 megahertz and step response, and the time base is at 100 nanoseconds. And this actually looks very, very good. I am extremely happy with that. So we're going to let that run here, and we'll check bandwidth. Okay, checking our bandwidth, and what we've got is we have a 50 ohm input coming from our HP 8642B. Needs about 400 millivolts of signal to get our 6 divisions and our leveled light to come on. So that's not necessarily a problem. But now we're going to frequency this 475 megahertz. And we should have a minimum of 4.24 divisions of display vertically with a carrier wave indicator, leveled carrier wave lit. We have a nice 4.5 divisions of display. So we hit vertical bandwidth at 475 megahertz, which is 75 megahertz over the 400 megahertz bandwidth spec of the 7854. So a little bit of an overachiever. Not bad. And we are right at 4.5 on the right channel as well, doing the same test at 475 megahertz. Vertical display modes we know works from playing around with this scope on the bench. Essentially, all that is positioning, that you can position the trace in both modes for vertical and horizontal. Absolutely, that works, no problem. The last step, which is examine the vertical trace separation using the trace positioning control, making sure we can position the B trace at least 4 divisions above and below the A trace. A trace is currently set to center, and absolutely we can roll it off the screen on both sides. On the F11, essentially what we're looking for is trace separation with the vertical separation control. The spec is I got to be able to position the trace plus 4, minus 4. So I can roll this up and down. I can actually roll it off the display. So everything is good to go there. Not a problem. This concludes the vertical section of this 7854. Hang with me. We still have one more section to go because we have to do the smart side of this scope, which is essentially the digital aspect. We have to do the digital section on this, and then this should finish up this scope and let it be ready to rock and roll. So a couple of things to do to get started on this particular scope, which is a little bit weird, is I have a upgraded ROM card in here. So the original ROMs that ship with this scope don't have the memory diagnostic card. There was another add-in card that you drop in, and you'd get this functionality, and you'd get the diagnostic patterns for the digital section. I bought the updated ROM card from the Vintage Tech Museum, and both firmwares are loaded on the card. So with the flip of a dip switch, I can actually get into the diagnostic section and take care of this scope. Now, that's going to allow us to do calibration procedure A. There's actually 3 calibration procedures for the digital section on the scope. There's A, B, and C. B requires the waveform calculator keyboard. A requires the ROM card, and C is getting it by but not working. We've done B on this particular frame before, and it didn't quite work out the way we wanted to. So what we're going to do is we're going to, because I have the ROM cards now, we've been through the frame, we've been through the power supply, we've been through the tube, we've been through the frame, vertical and horizontal, and we're into the digital. So we're in the home stretch, and we're almost finished. Okay, booting to the test card and showing the storage section. Here's the scope, actually both. Here's the scope section. We can turn that off. We want it just on stored. And we have our dot grid, and we can see we're off a little bit. So, and it looks like it's off and down to the right. So we're going to have to adjust the RO on the vertical, as well as the horizontal gain and horizontal offset. And let's see what we can do to make this a little bit better. So horizontal offset is R1205, which is up here. Vertical offset is, vertical offset is over here. And the best thing we do now this is waveform readout centering, gain adjustment. And then we do vector offset and gain adjustment, so we do that next. But for right now, we're on straight readouts, not vectorized graphics, but straight readouts to get this lined up. Ideally, centered and horizontal and vertical, and this grid pattern should line up with the intersections on the display. Okay, into vector alignment, but if I go to Graticule and in vectors, this is looking exactly the way it's supposed to. There's no bright spots in the vectors, so the timing is good. Everything is good. The vectors are lining up on the crosshatches like they're supposed to. So this is actually timing in very, very good. I don't see any problems with the display generation or timing with the XY generation or vectoral generation of this particular display. Sorry about a little bit of the screen flicker. Won't have this up too long. The characters do need to be adjusted. The character block is shifted down a little bit, so I need to bring the offset up, and then maybe the gain just a little bit. Offset's going to be R1106, and vertical gain is going to be R1100. So for 1106, essentially evenly spaced around the screen is what we're going for. To check displayed characters, flipping to scope mode. So if we go to stored character and we go to scope, we'll have the numbers back up here. What we're looking for is a good identify, nice and legible. Everything's good to go. So that will work. And that's it. That is the completed display alignment of a 7854 using the diagnostic memory card and diagnostic firmware. So to flip this back, what we're going to do, turn that off. I need to get in here and flip a switch. Pop that to number 1. Now, this will, actually we need to pull this off. That'll boot up now correctly. Self-test complete. Well, I thought we were getting close to done, but we're still off just a little bit, and I actually figured out what's going on. There's an entire section of the service manual that I hadn't even seen yet because it's below the 3 sections of the digital sections. So we've done the digital section. That was pretty short, and so I'm going to lump in the vertical and horizontal pickoff system into this section. So we can see the waveforms better. Not quite perfect yet, but better. And the next section is actually going to be aligning the digitizer. So let's get into that and see what we can do to improve that. This is much better. I'd say it's about 50 to 75% better than it was before we started. Okay, there's a fair bit going on here to set up for the digitizer section. So this switch needs to be in B slot. This connector needs to move over 1 port to the right. The front panel plug-in needs to be on TP523, which is right here. And a jumper wire from the sawtooth out to TP502. That's 520, not 502. Where's 502? There's 503. It's right there. And TP502 is the empty end of the resistor. And the sawtooth output is the third BNC up from the bottom. So we should be ready to do this adjustment. Let's see what happens. Okay, we're going to start this thing up. I do not want any smoke. It looks okay so far. No snap, cracks, and pops. And we're booting. We booted. Okay, that's good. Okay, let's see what we get for waveform. Forgot a step, and this explains why it was confusing. You need to remove the IACQ, or the acquisition jumper. This is off the MPU mainboard. This is the main processor of the scope. Do you have to pull this board out with power off? Definitely do not pull this board out with the power on. But I got to do that, and then hopefully we get the right waveform on the display. Okay, I'm supposed to have positive and negative going pulse widths. I don't, so we have to keep going with the digitizer board. Next, we need to leave the jumper off the multiprocessor control unit, but we need to disconnect everything and continue on. I'm using modern equipment, so I'm able to get this a little bit closer to center this, bring this down. Oh, wrong way. I want this centered on the graticule, which is right about there. And to clean up the waveform a little bit, I've got the scope set to averaging 8 averages, but DC coupled. So it cleaned up the noise a little bit and let me see what the overall average DC level was at, which is what we were looking for. Now, as always, because we have two sockets, we need to bring it down a little bit more. It was high on both, so I'm supposed to compromise this setting so it's best for both. So since it's a little high on the left, I'm going to bring it just under, about right there, and that should compromise right and left, give me the best results. Okay, we had to move the time base over to the vertical and the standardizer over to the horizontal, B and A, and I also had to move, we had to move the scope probe to P64 pin 2. Same thing, zeroing, DC centering the waveform on the MS1104, and it's off by about 1 division, so we'll bring it down. Okay, here's our DC level. Looks really, really good. Also, when I said it was 1 division high, it's because I have the scope set to 20 millivolts per division as opposed to 100 millivolts per division, so my differences would be a lot higher. Let me show you where R45 is. That one was kind of a nightmare to find. Okay, looking into the front panel onto the back plane, R45 is way back here. That's what we need to adjust for the front DC centering. So that one was a trick to find. I did have to move the standardizer over to this port because when it's in the A horizontal port, it's covering up the adjustment pot. So that's obviously not going to work. All right. Next up, we turn off the unit again, and we have to install that jumper. So we have to pull out the processor board, which is here, like so. Making sure we take all of the static precautions and all of that good stuff that goes with working with vintage MOS equipment. Make sure that's seated properly. Now the scope should boot again. As we boot back up, because we did adjust the center, the DC center of the sampler, we are going to need to adjust the, oops, I need to move these. We are going to need to adjust the sampling windows. So if you touch either of those two potentiometers, you have to do step H6. So we'll kick that on, let it warm up for a bit. Okay, we'll zoom in here. We can see my stored and my normal. Now, they are offset, but here's exactly where we were having a problem. Vertical sampler offset. I need to bring this line down. The adjustment is going to be 280 on the Digitizer board A25. Okay, took a bit, but we have vertical sampler, and that's the scope. There's the sample, and there's the scope. So they are overlapping very, very nicely. Gonna have to do this again, but we're gonna do it in the vertical compartment. And we're getting very, very close. Okay, I think we're looking pretty good, although I deviated a little bit from the alignment routine in the service manual because it kind of didn't make sense and was a little weird. So I ended up taking a very stable function generator, throwing about 100 kilohertz sine wave in it, and adjusting the vertical and horizontal offsets to make that waveform line up. I still have some windowing problems, which I can show here in a minute. However, my line is exactly where it should be, and my vertical offset should be plus minus 100. We are 32.96, so we're within spec. Everything is good to go. where I'll check the horizontal next, and I've spent probably 30 minutes adjusting these two potentiometers, so it's been a fight, but we're getting close. Okay, this makes far more sense today than it did yesterday. This scope actually got me pretty close to brain dead last night. Getting this digitizer lined up can be mind-bending, and I backed into the calibration the hard way, apparently. The thing that I was missing, and I didn't quite understand, was to get the lines that you're supposed to adjust, acquisition has to be running. It can't be stopped. So the busy light needs to be on because that has you put the scope in a mode where the acquisition never finishes, so you can see what it's doing and you can adjust it. I did it trial and error the hard way, backed in, but HCRD is 5, VCRD is 0.32. So we got it tweaked pretty good. If I move the cursors, 5.02, so we are dead on 5, exactly where we should be for digitizer horizontal and vertical centering. Okay, the way the digitizer alignment works is as soon as satisfactory alignment or satisfactory performance of the digitizer can be confirmed, you don't need to go through the rest of the alignment because it's relatively square. It's now digitizing very nice waveforms. This is a really hard waveform for the digitizer to hit on this scope due to the fact that the rising edge is so sharp. Well, it also helps when you're dirty switch. Helps when your waveform doesn't go away in the middle of digitizing. Given that this rising edge is so steep, it's kind of hard for this scope with it, even though it has a 10-bit digitizer and everything like that. This is a tough one for it to capture. But if we hit acquisition, and both, actually we'll do just stored. It didn't get all the way up to the peak, but it was just the digitizer missing it. If I had just done single shot acquisition, these would be all over the place. It's just how it's sampling. But if we give it a ground reference, just below -2, not a problem. And then we take the midpoint. Should put a line about 738 millivolts. And then we take a period measurement, 955.8 microseconds per period. I have 1 millisecond averages going in, which would be 1 kilohertz. So the digitizer is running slightly slow, but I'm pretty happy with this result because it would be 9.99 or 995.8 minus 1,000 over 1,000 times 100 means we're running slow by 0.42%. That is fantastic for this scope. These 7,000 frames typically hit in the 3% range. The spec on the 7854 is much, much tighter than the rest of the frames typically, at least from what I can find. But we have a well-aligned digitizer, and it's really behaving. Also, the digitizer is from the 2nd to the 10th, not the externals. So I believe we are finally finished with the alignment of this scope, and I can put the covers back on it and get this back where it goes on the bench, and we can actually start using this in the lab coupled with the 7603. Thanks for stopping by the lab and taking a look at the mind-bendingly complex alignment on a 7854. If you like what you're seeing on the YouTube channel, hit all the YouTube buttons, like, subscribe, and bell. And if you'd like some additional content from me, take a look at the Patreon page. Patrons are running a little bit ahead of YouTube. At the moment, as of the recording of this, there's nothing behind the paywall. It's just early access to the content that will eventually come up to YouTube. And their assistance helps keep the lights on and videos coming up to YouTube. I will see everybody in the comments section in between videos. As always, more is on the way, and I will see you guys in the next one. Bye for now.